Hello world, we are live. In this, it's not even a stream, I've disabled the kind of interaction. This is more of a live broadcast, a tutorial. I'm gonna make not one, not two, but three simple mini micro games. It's really a showcase of game mechanics using Python's time module. It's part of the Python standard library. So transition and go to the Raspberry Pi code editor, which I have here. I'm also going to look up the Python standard library time, time access and conversion. This is part of the Python standard library, which means that which means that you don't have to pip install anything or anything like that. Quite a new project. The first game I'm going to call, just calling this wait now, or like maybe wait now. It's like this. Collapse this, make that bigger so I don't forget. No, like this. It's quite big. 125, 110. Okay. Time. It's not. It's just going to talk through the settings. The thing about time, right? You import time. You just import time as one does. And then I've got access to several things like, say, not print, but time.time will give you. There's no shortcut to run. That gives you. This is the number of seconds since the 1st of January 1970. There are historical reasons for this. We don't have to worry about this, but this is in seconds. Then time will give us crucially a lot of way of converting it to sort of like, formats that are better suited to humans. What we can then do there's also time.sleep where you pass a value in second. So if I rub this in a loop, say 10 times this, and then select an indent, this is going to, well, we'll see. Wait a minute, wait a second, print, and you see that number is going up. So immediately, I'm sure that some of my more regular viewers will have see this and like immediately see all of the possibilities. So let's do the first one. The first one is wait now. Let's put that at the top. Wait now, a reaction time game. It's really, I mean, to be fair, it's the essence, it's a game mechanic. In the previous stream, I said that Cookie Clicker was kind of distilled the essence of many a video game where it's essentially you get a number to increase by doing something, and then that gives you something you can spend onto making that number increase even faster. Well, there's another type of game, which is essentially how quickly can you react. So we are going to we're also going to import random. I'll explain. Well, it's going to become apparent in a second. Import time, import random. Actually, I'm going to even probably do from random import randint for the random integer. And what I'm going to do is rand. Wait. And then I'm going to wait for between 1 and actually I'm going to do you know what, import random, fine. Because I'm also going to want random. So sleep random dot randint, no, random dot random. Random not random gives us a random number between 0 and 1, and I multiply this by 3. So that we're going to sleep, because I don't want it to be 1, 2, or 3 seconds, because then I could kind of like, well, I don't know, I want it to be like really a random thing. So any moment, we wait for a random amount of time, and then we're going to take the time, or kind of acted. Well, call it T0, right? Like the time at which we display. So that's going to be time.time. And we're going to print now. And then, no, we're going to input. What? Input now. So this is going to print now and then wait for the user input. And then once I get the user input, I'm not doing anything with it. So this would return something, but we're just going to discard it. And I'm going to then take another stopwatch measurement time.time of T1. And then I can say difference reaction reaction is equal to T1 minus T0. This is going to be in seconds. And then I'm going to print, I'm going to use an F string, U reacted in curly milliseconds, and in the curly is going to be reaction multiplied by 1000. So I've got it in milliseconds, and then colon, and I'm going to format it with like, I keep forgetting, it's like dot to F. I really hope this works. I keep having to look it up. Let's try it. Sleep is not defined because it's time sleep. Time, not sleep. Right. So I need to have the focus. No, that was way too long. Okay. I don't know if I've got focus immediately. I hope. I do have focus. Okay, so what we're going to do is wrap this into a while true. Capital T for true and false, remember? And then can put it there. Oh, okay. Oh, hold on. I wasn't ready. Hey, that's too fast. Okay, I don't like that it should be at least 1 second, right? So 1 plus this. So at least 1 second and a random amount of seconds between 1 and 3. Okay. Wait. That's so the typical reaction time is 300. I can't. Okay, well, my younger viewers whose nervous system is like wiring is still sharper might sure do better at this. Okay, we can spice this up a tiny bit. Not much, right? But I just wanted to have something like here. If I make an F string, I can inline have something like this is going to be the letter A, but then that multiply by like a random between 1 and 5 A's. So, and it's going to be different every time. Mine 6. Hmm. Maybe I kind of. Ah, yeah, I can't do that because, yeah, no, if I do it like this, different diameters. I need to have a single quote. So there's the character A, but I multiplied by this to include into that broader, larger string, right? It's pretty good. So I just kind of like putting it like random number. Wait. Okay. Mm. Cough and mute, cough and mute. Actually, mute and cough. Okay, so that's wait now. This is the first one. It's less promising than the others, although it's really distilled to its essence. The problem it has is that you can spam, right? So if you're always tapping, then you can, I mean, even like if you kind of always tap, the way to pick it up, it's like the frequency of your tapping. If you can tap, but you would have to tap at 10 hertz to kind of like, get it there. But you can still kind of get it in the right range, which means that, for one player where you kind of, as an experiment, it's control conditions, whatever, that's fine. But you can't really make a multiplayer game out of it because, well, no, you can't really make a multiplayer game that I would show to like a class of 14 or 13-year-old because, and kind of get them to play because one of them is going to find out that you can spam and that's going to cause contention. No problem. We get more options. New game? No. It's just like a saved. Cool. New game. Okay, the next one, Elapse. Now this has got a lot more scope even for extension because the basic mechanic would be import time, and then print tap return. So it's about measuring how well people can keep time. So if I make this an input, and then I take again a t0, and that's time.time. I put another input in here to wait for the second one, and take that time. And then I can say something like, so elapsed is equal to t1 minus t0 in that instance. Okay, I'm, diff is equal to elapsed minus 1. If diff is larger than 0, not print, what am I doing? Yeah, I'm not going to do an over under. I'm not going to have to worry about. Yeah, I could still. The diff is going to be useful. So I say diff print f diff difference curly diff. So it's going to be in seconds. The same deal. Minus multiply 1000 colon dot to f close curly ms milliseconds. And that's it. That's the second game. No, well, that's the beginning of second. Okay. So I'm kind of like trying to get a sense of beat first, and I think it helps. Oh, yeah, because it's a float. Yeah, we can't D for decimal, so it comes from another language. Okay. Not bad. I'm like well impressed. Positive difference. So that was too long. Elapse minus 1. Let's rub this into a while true like we did for the previous one. Just so I can play around with it. Okay. Subtle. Okay. What's interesting is that it gets much harder the longer you have to wait, because counting 1 second is something on it. So we can do something like, okay, target starts at 1. Going to make that an F string. This is when the syntax changes, right? This becomes black to say that's syntax, not string. All good. I might also do something like percent is equal diff minus. So this is still in seconds, right? No, so this is elapse minus target, right? And so this is in seconds. Oh, this little cat. Yeah. The other one is cuddly too, but like not kind of, on lap cuddly. Okay. I get more than one cat. It's like my cat, one of my cats. The purse is what I meant. Perk, the percentage, is equal to the diff divided by the target. And we can multiply this by, yeah, it's the diff divided by the target. Actually, it's the apps of the diff. And direction is equal to, so instead of doing an if statement, we can put an if statement on one line. So we put the then first, so it's going to be over if diff is larger than 0, else. So it's not really a real if, it's like a variable can take two values, it's kind of a else under. It's quite nice. And this can become you where direction by. And so this is going to be, yeah, and then I'm going to set a target becomes, well, becomes equal to target plus 1. You can do plus equal 1, but I want to keep it simple. Um, okay, 1 second about. Oh man, this is like, well, mind you, sorry, I don't have the percentage because like my scores are seem like they're kind of similar, especially that's really bad for 1 second. But I seem to be off by that, although that's increasing, so I am getting better. Uh, and we're gonna say we are going to say um, print f quotes bracket like a little text bracket and a curly bracket to say pers percent. And pers formatted as, so it's already in percentage. We don't need to multiply by 100 because we've done it over there. Um, because it's the percentage, right? Because it's a ratio, it doesn't matter whether we do this before or after the conversion milliseconds, but this is a note between, you get it. Anyway, so all I need to do is format it in .2f, .2 float, bracket percent. Okay. Um, Not bad. Yeah. So that I can even I need to close. I might put this, I might put this just like actually, put this on the same line. Huh. I'm going to put it first actually by this and then in brackets the milliseconds. So space, no, space, open bracket ideally. Up here. And then this I can remove. Mm-hmm. 1 Mississippi. Okay. Not bad. I mean, 66, 3 point. Okay. Okay, so that's quite good, especially because you can make it to different targets, and then you've got two different values to kind of tally up as scores and so on. So I'm just talking about this as a mechanic if you include it into a broader mechanics. So in particular, this is something where you could start going, okay, so you start by actually taking, asking the number of players, and then for each player you take their initial, and then you make a turn-based game where people try and kind of get as close as possible. You can then have maybe an elimination system where like people said kind of who's the one that was closest for the round, and or like you could store point in that, like you want to have the least number of points, and the points is the total of the differences in milliseconds or of the percentage that you accrue over the gaming session, and with leaderboards and so on. So this is when the moment you get like numbers, and then you can like so this like two-dimensional data structures. You can read and write to files if you go fancy and so on. So that's why I'm kind of my weekends are like demoing the basic mechanics and then try and adapt into lessons for my classes, with various degrees of success. But that's Elapse, right? Measuring time. Um, there's stuff about in the same way you can, like for musician, you can say, hey, can you tap, I don't know, 80 beats per minute, and then you can figure out how close they are. It's a bit fiddlier because this kind of like alignment is like just the average BPM, and also versus do you want to also keep them in time? So you could count them down by displaying something every beat, and then they take over. So like you count down, and they start on zero, and they need to tap. This is a more complex one. So I'm not going to do this one. I'm going to do another one. Uh, can I just do not new from here? Oh, it's here. No, it's there. No, it's it's somewhere else. Fair enough. Project and a new Python project. And this time I'm going to call it Quigo, closest without going over. Classic game mechanics from blackjack to The Price is Right, I guess. So same as it's kind of actually I might even no, I'm not going to adapt it from this. Um, so closest without going over has to be a multiplayer game. So yeah, fair enough. And equal int input number of players, and then for I in range n colon players start as the empty list. Yeah, that's good because I can demo a bit of multiplayer. There's this kind of multiplayer like gaming design patterns, right? So this kind of thing where it's turn-based, you kind of always going to at least start with this kind of code. So you take number of players, you initialize a list, not just for players, by the way. Right? When you want to ask the user to populate your list, you do it like that. The other is to have a terminator to say keep entering player names until you enter stop, and in that case, you would be using a while loop, indefinite iteration. So for each of those, we're going to append simply input f player hashtag number I plus 1 because we're going to be counting from 0 to n minus 1. Player number 1, colon space, that's this. Okay, let's do the same thing. We can always write, well, we can, why not? Target equal 1. No, let's do one round. Let's not complicate it. Iterate, test it, something basic, test it, build up on it, rather than try and more often you run your program, the better, basically, even if it's not finished. Target 1 second to start with. I am, well, am I gonna? Yeah, I am going to open this in another tab and have another look into Elapse. Elapse, and use the same thing, like pretty much the exact same code, but, well, okay, I'm just going to copy all of this and then I'll edit it elsewhere. But this time I'm not going to let them go over, so I want here, this is kind of slightly different stuff. Just leave it in the same because I might reuse some of the percentage calculation and so on. If, not in capitals, if, no, here, if elapse is larger than target, print. So now we know, sorry, we still want a for player in players. And for each of the players that I've just say, we're going to go. Going to go print bracket f. Well, this one I'm going to do like I might do like player plus space double quote single quote apostrophe s. So it's like sorry double quote apostrophe s turn. Right, you see what I'm doing there. Then we do the first thing, the kind of like 2 beats and so on. We get the elapsed, and if it's larger than target, we print Oh no, that's good. I know what I'm going to do because yeah. So let's do one round. Bunch of the players. Well, this is going to be like each of them. If Elapse is larger, else then we can go. The diff is Elapse my target in second. The percussion is we don't need the direction, and we are going to. Um, hmm. I'm not even going to want to use diff actually. I'm going because Elapse is already whatever percent of because this is now going to go. You came 98% close, 99% close, so we don't want to be. You were close by. Um, we want you came as far as. So now the percentage is this. We're not really using the diff because it's not meaningful, especially if it's absolute rather than relative. Um, so hmm. You came whatever percent close. We're not incrementing target for now. Just gonna take this up a bit. This needs to be indented. That should, let's see what it does. Okay, number of player, two player, and A is playing against B. A's turn. Okay, A is going to go 1 second apart, but I want an undershot rather than an overshot. Right, so B's gone because A's gone over. But if they have both, well, obviously, like at the end, one would have come close. Um, so no, see, I haven't thought this one through enough before starting streaming, because what I would like to do then is that okay, if like let's have something where they don't go over all together. I could take anyone who goes over out and then keep increasing. That'd be quite devious because now you don't. It's not almost like closer by not going over because you don't really compete. Like if the elimination is always going over, that's not really right. But yeah, uh, still we can have something. Now we can have something where, well, true. What has happened? What has happened? Oh, I've collapsed. I've collapsed this. Yeah. Okay. Well, true. Colon. So forever, essentially, we do this, and okay, displaying the winner. Displaying the winner. I'm gonna write it actually. Displaying uh, the winner is left as an exercise to the viewer, because I kind of want to have lunch and I've got a train to catch. Here we now increment target. So this time I'm doing the Pythonic one. Um, plus equal 1 to increment, or plus equal whatever to add, and plus equal 1 increments by 1. Well, one player. I actually close without getting over. I don't know why I did a two-player game, because it's just like you get. It would make a good one-player game when they keep increasing, and yes, okay, that's A. Okay. Well, then there's no incentives because like I can play it safe, but this is where if someone else was there, that would be that. Um, although closer without going over would probably be better if you start with kind of longer ranges and targets and kind of bring them further in because it technically gets harder, right? Because you've got to get there. Minus, minus, minus. I don't know if I can link to my projects and people can see them. I've not found it like a share, download, main.py. I mean, I can. It's not like super complicated code. You've seen the stream. Those were free little projects wait now, elapse, and close without going over. This one's been done as a two-player game, and I kind of copped out because the moment you want like more than one player, you need to have logic to decide who's the winner, and then have kind of round structures and so on. You can ask number of players, you can ask number of rounds, you can ask for targets, or like kind of say we're going to have like 2 rounds of each for up to 5 seconds, etc. And you could do that for elapse too. You can't do it for wait now because you can't prevent uh, a key press like you're technically listening for the now even before you said now and there will be content as true. You need to figure out well no you can't no you can't, that's not possible. Yeah yeah I would need you need to basically block user input until you've said now. Or sorry, like actually detect it's what you're doing. We're looking into user input until we said no because it's just well, I don't know what you've got the code there. I just what I mean here. Let me actually if I'm going to speak about it, let me show the code. What I meant by this, right, is the problem we have with I'm going to look into making a multiplayer game because if I with an event listener, that would be really a good way of introducing the concept of event listeners and the idea that sometimes with interrupts and you need to basically be doing something else, even if something else is waiting and disallowing anything to come in, but still detecting that something has come in, so you can disqualify someone that would be if you receive an input between here and there. You should disqualify them. Whereas here you're able to spam, 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 and then the first one you hit after the thing will register as that, which means you can go right, right, when in fact, in reality, I can't barely do more than, yeah, getting it under 350 would be good. Under 350, I said. Curse you, nervous system. Tune in next week for my next stream. Mr. Burrell plays this his reflex game forever, but this is actually fun. I mean, and you know, this is like there can be even fewer lines than this if you don't fancify it like I did. So, the moment you have a stopwatch, you have a game. If you ever play with a stopwatch, you know this. Thank you for watching, and I'm sure we will